Okay, so well, what we will try to do today, just give a general overview of what is statistics, probability and statistics. They're very um, connected. And so this is the address for the notes. And we have one Jupyter notebook for it. Okay. So when we have a data set, the least thing we can do, or the first thing we can do, is do an exploratory data analysis. And the exploratory data analysis will give you the information of 5 variables. And we will have the information for the mean, the median, the variance or standard deviation, and the maximum and minimum of data set. And we don't have to know anything about the statistical distribution or probability distribution function. Just the basic numbers that give you an idea of how the data set is behaving. So the idea of the exploratory data analysis comes from John Tukey, and it's the 5-number summary which describes that data set. And there are other options for like a 7-number summary or even a 9-number summary. But basically, what you need to know is what is the median for every data set variable. So this is the median. This is a box plot. This is the median value. That's the value that just lies in the middle of the data set. If you have 100 data, the value that is sitting on the 50th place is the median, if you order them. And then you have a minimum, a maximum, then you have the quartiles. The quartiles, in each quartile, the data is 25% of your data is distributed in that quartile. Okay, so that's the exploratory data analysis. And these are the data that come back from exploratory data analysis. The minimum, the maximum, the lower quartile, the upper quartile, and the median. And okay. And then also the exploratory data analysis will let you know if you have outliers. Outliers are data which are lying outside some range, and you can Tukey defines an interquartile range. The interquartile range is just the difference between the first quartile and the third quartile, or the size of this large box. And then whatever data lies above the third quartile plus 1.5 times the interquartile difference is going to be an outlier. And everything that lies the lower quartile minus 1.5 the interquartile, like this one, is going to be an outlier. And there are other types of or other methods to decide what is an outlier and what is not. But that's basic 2K proposition. Okay, so we know this type of data, this type of variables or values. And then for data visualization, we can visualize histogram, box plots, scatter plots, correlation matrices, and then they will help us define which are the outliers or the trends. If we have like a time series, then we can compute a trend and see how if the series is increasing or decreasing. We have to do the data cleaning when we have missing values. So how are we going to treat these missing values? Are we going to just delete them, ignore them? Or what? And also, are you going to include the outlier sometimes we have a data set and then let's see, we have a data set and then we have an outlier or something, some value that is way off, and we need to see if that data is real or how did it got there. Maybe it's just an error in our measurements, or if it's there, then sometimes we have to include the outliers. So that depends on the problem you're studying. Then we have analysis for one variables. You have to do the summary statistics. We will show you how to do it in Python. Or we can do a bivariate analysis when we examine the relationship between more than one variables. Doing the exploratory data analysis, we're trying to identify patterns, trends, anomalies, and then we can generate some hypotheses as a research question for our data. Okay, so those are general concepts you already know probably. Seaborn will be the Python library that is good for doing statistical visualization. And also Seaborn, as I mentioned, is built on top of Matplotlib and also integrates well with Pandas. And comes with different choices for styles and color palettes. And is very easy to use. We will show some examples. Now, what if you are not very good at programming? Then we have these low-code exploratory data tools. They will help you clean the data and doing all the data analysis and also essential visualization. So you have a general overview of what data is there. So let's go. These are Jupyter notebooks. Let's open the first one. And we can open this notebook in Colab. So let's open it. Tell me if you are there. And I'll just go over to an overview of what this notebook does. Resources. Let me go back just a little bit and post the notes. Okay, thank you. I wasn't here yet. Went to lab. And I'll just overview what is this notebook is doing. Okay, so we're going to use this data set, which is wine quality, and we need to install this library. Run anyway. So we're going to study a data set that has information of 5,000 kinds of wine, and it's measuring 11 different properties of the wines. And we have a question that we need to answer, like what makes a good quality wine? Is it its alcohol content, sugar content, or what? So that's the question. Okay. Thank you. It's failing. Let's see if it works. So I'm going to use NumPy, numerical Python, Matplotlib, Seaborn, Pandas, and PyWalker, which I thought I installed. And okay, so the question is about wine qualities. We're going to read two files from the internet. One is the white wines and one is the red ones. And then we're going to use Pandas to read the CSV files for the white wines and the red wines, and they're separated by semicolon. So I read the files. I see how the white wine data frame looks. I print the first 5 rows using the head function. So this is the white wines. This is the number of wines they have. We have different variables: fixed acidity, volatile acidity, citric acid, residual sugar, chlorides, etc. And the red wine also has the same information, same variables, but on red wines. And then these are the names of the columns or the variables. And what we're going to do is we're going to add we're going to add a label, white or red, for each data set. So we're going to generate that. So the next time we will have an extra column. Now we can use the info function, which is the exploratory data analysis. I can run it. So this gives me a general overview of my data set of the white wines. So it has 4,898 entries. Remember, Python starts counting from 0. So row 0 to row 4897. These are 13 columns, and these are the names of the columns from 0 to 12. The first column is the fixed acidity. The last column is the type. And also we have the number of entries. So the first column has 4898 entries, and almost all the columns have the same number of entries, so there's no missing numbers. And the type of entries are just floating numbers or real numbers or digital, decimal numbers, except for the quality, which is an integer. The quality is just 1, 2, 3, and the type, white or red, is an object, just a string of characters. So this is to very basic data exploratory. The same thing with the red wine, and we have 1,599 entries, the same column names, the same number of entries. They don't have missing numbers. Almost all the variables are decimal, and except for the quality, which is an integer, and the type, which is the label red in this case, is an object. And then we're going to merge the two data frames. So we're going to have only a single data frame that includes red and white wines, and we can distinguish a red and white wine by the label red and white, which we added a few moments ago. And now this is the full thing. Now we have 6,497 entries. So we have joined the red and white wines data frames into a single data frame. And then we can see what's the first lines using the command head. The new data frame is called wines_df and has everything, all the information. Then we can group the data frame by quality and type. So all the rows will be organized by quality. They have the same quality and the same type. And let me take this out. So the first rows are now all the wines of quality 6 and white. And then up to the last rows, which is quality 3 and reds. And then we can use PyWalker to do the exploratory data visualization. So I'm going to use the PyWalker visualization library to analyze the wines data frame and cross the fingers and it will work. Okay, so it worked. So this is I can inquire about the quality and um, color. Let's see, is it doing something? Yes. I don't think it's working. No.
I had trouble on your very first line of code in terms of installing PyGWalker.
Yeah, it came
Had some
back
kind of
as
dependency issue. I don't know if it worked or not.
probably that is not working. Yeah, we have some errors. These are new. So I will need to install all these, make it work, and also do the installations in specific order, because if one of these libraries, let's see, I'm going to code, just going to try. Let me 2 minutes. So pip install without install, and then whatever library quiet, and then copy, install fast API.
So Lida must be a dependency of PyGWalker.
PyGWalker needs all these libraries.
Needs them all, but some kind
Yeah,
of
so you see, I need to
conflict.
install first Kaleido or Python multipart. Okay, so let's
Okay, so
try.
you're gonna try to do them each at one at a time.
You
Requires
have to know
fast
the
UVCar.
exact sequence of installation. So
Yeah.
let's try now.
And also you might need another version.
Yes. Yeah. Are we in time? Yeah, Python multipart now first. And unicorn. Okay, let's go back. Codes. Pip installed. Let's try unicorn first. It will require Python multipart. Okay. Yeah, needs a Python multipart first. Code. This is the fun part.
Absolutely.
Remember, for reproducibility, I wrote this Jupyter notebook a year ago. Now it's not working.
Yeah, so is there a way around that when you do all your installs, you can specify version, but the problem with Colab is it has pre-installed everything up to the latest versions, right?
Sometimes, yes.
Okay. It's like, is there a way to install the version you want instead of using Colab's pre-installed versions?
Yeah, so now I installed Python multipart, didn't complain. So next one is unicorn. Hopefully it will not complain. And then install Kaleido. Yeah, because depends on Python multipart. and unicorn, and crossing our fingers, right? Yeah. Now we install the Fast API, which requires the previous 3 libraries. And then after that, we can install again PyWalker. Yeah.
Simone is asking in the chat if you could just put them all in the same block
Yes.
instead of
But
having,
it's,
doing a new code block for every single one. Can you just put them in order like this? See what he's saying in the chat?
from experience, don't put all your eggs in the same basket. I mean, if it's something going to fail, at least you know
At least you know what part failed.
what part failed and what needs to be installed. So
Yeah.
if you do it independently, then you know what goes first and what goes later. Now, we don't have any errors, right? So we can delete this one. We can delete this code, yes. And then, so now we do it again, and everything is in memory until we need to run the PyWalker.
Okay, you didn't have to run all those again? Okay.
No, they are in the memory. So now we run this one. It shouldn't fail because now it has met all the requirements. Okay.
What do you think? Yay, nay?
Wait, it's doing something. Doesn't like to work under pressure. Okay, I think maybe, so you drag and drop, fix it, drop here. And then quality, yes. So it's a drag and drop. And then you play with this. Confirm. I'm just doing it blindly, have no clue. Density. All right. I don't know. Yeah, so you just continue plotting. It's going to be similar if you have used Tableau, which is a commercial visualization library. These should be similar. But anyway, let's continue. Doing it the old way. The old way is just using matplotlib to create the plots and Seaborn. And this is the distribution of the wine quality and colors. So this is the wine quality rating from 3 to 9. And this is the number of bottles in the database, white in red and red in beige. And then this is the criteria from TACAE to detect outliers. So if something is below the first quartile minus 1.5, the quartile range, which is the difference between the third quartile minus the 1. So this is the quartile difference. And everything is below that one will be outliers, and everything above 1.5 plus the third quartile will be outliers. Okay. So we compute the outliers, and we have on the first quartile one value. These are the values for the first and third quartile. This is the lower and upper, and the number of outliers is 49. In the fixed acidity, in the volatile acidity, we have 19 outliers. In citric acid, we have 1, etc. So we have identified the different outliers, and then we can do the multivariate plots. And this is the fixed acidity. And then what am I doing? I just need to make a plot. So a graphical plot gives you more information. This is how every variable is distributed, and you have some variables with lots of outliers. Okay. So for example, the total sulfur dioxide has a lot of outliers. Okay. So, well, I didn't want to go into too much detail because this example is kind of complex. But the idea was trying to answer what makes a good wine. And so we scale. Terrible wine will be anything below 4. A phenomenal wine will be anything with quality greater than 7, and the average quality 5 or 6. So we do that, and then um, we get the chemical distribution across the red wine of different qualities. So this, you have the terrible wines and the phenomenal wines and the average quality, and these are the components of the proportions of the different components. And then you can do scatter plots and see what is how the wines are distributed according to the citric acid and the alcohol as volume. So we can do relational plots, and then we plot residual sugar versus alcohol content, and seems like the more alcohol has, maybe it's a good wine. So everyone's happy. Okay, so let me go back because our time is going to run. Come on, where is it? We're doing what statistics? Sorry. Okay. Okay, so that was an example of exploratory data analysis. And we have low-code exploratory data analysis. Yes. Okay. So the idea of the low exploratory low code, we open this one in Google Colab. So now I will show you other libraries similar to PyWalker to do your exploratory data analysis. And we have several options: the wide data profiling, the suite visualization, looks apply, the data prep, uh, and the auto-base. So let me install the Pandas profile requirements. So I'm going to install some notebook requirements and extensions of the Jupyter notebook. Run anyway. And you will see that only takes a couple of lines of code to do all the exploratory analysis compared to what we were doing in the last notebook, that we had to go into the detail of computing all the different variables and trying to plot different ways the data in order to extract some information. So, okay, so hopefully this will run. And actually this does it. this session is two parts. So next week we will continue with the second part. So that's why I'm going into detail. And you will end up with different Jupyter notebooks where you can try it in your case for your data. Okay. Okay, so it installed. Very good. Oh, come on. We have the same thing again. So the idea, yes, so we need to add several codes. Let me go back here and code. And let's start the other way around. TikTok, what is this? TikTok? So pip install, assuming I'm writing, quiet, no, what? TikToken, quiet, okay. And then we, oh, what? Cohere, OpenAI, Open AI. Oh, okay. Let's go back, code, code, pip install, quiet, what? OpenAI. We don't have any API. Okay. And then Cohere. Okay. Oh, come on. Come on, close that. Coding. Cohere. I don't know what that library does. Okay, so Cohere's up, and then I will just make it go low, and then OpenAI again, and then so now we can install TikToken, and then we need the next one is what? Unicorn, or was it the multi-part? Distinct change by the months. And then, yeah, the multi-part needs to be before. So code, pip install, quiet, the Python multi-part. Okay, shift enter. Oh, sometimes I think this is random. Okay, let's try install the Kaleido. And then the fast API. Yes, the fast API. Okay, so I can install Kaleido. Then I can install the Python multipart. Then I can install the Ubicorn. Okay, what's next? Okay, so we have some requirements. Let me delete this part. Don't need that, don't need that, don't need that. So we got the error here. So let's try again importing Pandas profiling requirements. Yes, no errors. Import NumPy, Pandas, and white data profiling profile report. Got it. We're going to read the penguins dataset over the internet using Pandas read CSV. Got it. We print general information, just how many rows, how many entries, what type of data. If you have missing data, we have missing data. And then we are going to drop all the missing rows with missing numbers. And we have the new data frame of 334 entries. Every row has the same number of rows. Every column has the same number of rows. We have objects for the species, the island, numbers for decimal number for the culmen length, depth, and flipper length, and body mass. And gender is objects. We can do a fast statistical analysis on the numerical variables. And we got how many entries? What's the mean of each variable? What's the standard deviation? What is the minimum value? What is the maximum value? This is the median value. And these are the quartiles, first one and third one. So the function describe gives you a summary, statistical summary of your numerical data. You can do the same thing for the categorical variables, which are the island and the species and the gender. Okay. Now we can generate the Pandas profile report just running this line. And it run. Now we will display and it will create HTML file, which we don't have anything here. I just let it finish rendering. So we have the report, it's rendering the report. And 24 seconds execution. And now it's finished. Okay, so this is the report, right? And we have this is the overview, 7 variables, 334 observations, no missing values because we use the drop NA. There are no duplicate rows. Okay, we have 3 categorical variables and 4 numerics. These are the bar plots for the species. So we have 3 species, the Adelie Gen 2 chinstrap. This is no missing. We have 3 distinct. For the island, we have something similar, Bisco, Dream, and Torgensen. And for the culmen length, this is the histogram. We have 163 different values. The minimum is 32.1. maximum 59.6. No zeros, no infinite, no negative, whatever. And this is the mean value for the Pullman length. And this is the histogram. And you can ask for more details if you want of like the statistics, the histogram, the common values, and the extreme values. So everything is there, okay? Histogram. And then the Pullman length, something similar. This is the histogram, so you can ask for more information, details, you can have the histogram. So it only needed one line of code. Of course, we had to install a lot of things, but this is what generated the report using Pandas profile. This is the report converted into widgets, meaning visual objects. And then we don't have anything in my folder, then I can run the next line and generate HTML report. And then this is the HTML file. So the widget, instead of having the big widget, I have an HTML file. And also I may have, yeah, I didn't save it. Okay. Okay. Let me close this. Okay. And I select the columns, column length. So it's similar to the widget. I just have HTML file. Okay. I have correlations. I have missing values, samples. So that's one library, the Pandas profile. The next library is SweetBees. I'm just going to use two cases, just for time. So now we're going to install the next library, which is called Sweet Visualization or SweetBees. Running it, so install it. Hopefully there are no dependencies needed, like Pandas profiling. So Pandas profiling requires so many libraries, additional libraries, in order to create the widgets. So now I'm going to import the library SweetBees, and it's now generating the report. So that's why it's called low code, no code. Couple of lines of programming, and then you have everything. Okay, so my didn't open HTML, so I need to open the results in my notebook. So here, this is the SweetBees results. I have the species, the island, the culmin length, the culmin depth, the flipper length, the body mass. I have all the information for the exploratory data analysis, the maximum, the minimum, the median, the average, the standard deviation, the first quartile, the 95 quartile, the first, and here I have the range, the quartile range, standard deviation, variance, kurtosis, skewness, and the sum for any variable, okay? So this is how the Bees library gives you the information of all your data set. So it's very neat. You don't just install it, import it, define which is your data frame, and then ask the SweetBees to analyze your data frame and then to show you the results. 4 lines of code. Okay. Any questions so far? So you get the spirit of what is a low code, no code. We have the API, Lux API example, similar. And I don't know, you want to continue reviewing the different libraries, or we should go back? Have you gotten so far to this point, or you are behind? What's the feeling? Do you find it useful? Okay. Started, we go here. Okay. Yes. So, Simon, you have the answer. Okay. Got it. So let's try this last example. The Lux API. Install it. Hopefully nothing is required, or already was satisfied what we did with the Pandas profile, the first one. Yes. Okay. A good experiment will be just starting on the second case and see if it works, or you need to install the same things that were required for running the Pandas profile. So now we have installed the Lux API, and then we're going to add some extensions to the notebook, to the Jupyter notebook. Okay, and then we're going to import the Lux API, we're going to import Pandas, we're going to set an output for the Google Colab and enable some widget manager, read the penguins dataset, drop the empty rows with the rows with empty values. This is our data frame. And then, so here we can toggle between the pandas. So I'm looking at the data frame, or I can toggle into the looks. So here is the correlation between the variables. Come on. This is the correlation between the variables, between the body mass and the flipper length, or I can look at the data distributions, the histograms for the flipper length, the body mass, the culmen length. Or I can do the occurrence, how many, for the categorical variables, how many penguins of are female, how many are male, how many penguins are from the Bisco Island, how many penguins are from the Torgensen Island, how many penguins are from the Gentoo species, etc. So this is Pandas, the Lux API. So I can toggle between the data frame in Pandas, or I can toggle between the Lux different visualization options. Okay. Okay, so I think you get the idea of what is a low-code, no-code visualization libraries in Python for doing the exploratory data analysis. So let me go back. Yes, let me go back. Oh, come on, I'm in the wrong repo. Workshops. Wiki. And then statistical inference. Okay. Okay. So we have reviewed what is the exploratory data analysis with low-code, no-code tools. And we have some examples. We saw this one, the wines analysis, exploratory data analysis, and the exploratory data tools, low-code. And you can find more information about these ones. And okay, so we are halfway what I want to do, so I will leave the second part for next week for doing the statistical inference and review how to do statistics with Python and what libraries we have available.